Good afternoon, everyone. I'm Aizelty Madera from BSED English 3B, and for today's discussion, we are going to talk about statistical treatment in data analysis. The term statistical treatment is a catch-all term which means to apply any statistical method to your data. Treatments are divided into two groups. These are the descriptive statistics and inferential statistics, which will be discussed further later on. But first, let's have the difference between statistical analysis and data analysis. So don't get confused. The difference between these two is that statistical analysis applies statistical methods to a sample of data in order to gain understanding of the total population, whereas data analysis is the process of inspecting, cleaning, transforming, and modeling available data into useful information that can be understood by non-technical people. The process of data analysis can be used as input into performing a statistical analysis, as data from various sources can be combined in order to conduct statistical analysis. Now let's have the descriptive statistics. It is a branch of statistics that aims at describing a number of features of data usually involved in a study. So the main purpose of this statistic is to provide a brief summary of the samples and the measure done on a particular study. Coupled with a number of graphics analyses, descriptive statistics form a major component of almost all quantitative data analysis. Descriptive statistics are quite different from inferential statistics. Basically, descriptive is about describing what data you have shown, and for inferential statistics, you are trying to come up with a conclusion drawing from your data or the data you have. For example, we can use inferential statistics to try and give an indication of what the population thinks from the sample. We can also use inferential statistics to judge the probability of something occurring based on the behavior of the sample of data taken for a study, while the descriptive statistics are usually used in presenting a quantitative analysis of data in a simple way. In a study, there are quite a number of variables that are usually measured. Therefore, descriptive statistics comes in to break these numerous amounts of data into a simple form. For instance, we are going to determine on how the students perform in the school. Usually, we use the grade point average or the GPA. This is just a single number that gives a general indication of the performance of a single individual. So the moment one looks at the GPA of a student, he can tell the potential of that student on the various courses that he or she takes. It is important to note that when using a single value to describe a large set of data, there is a possibility that you are going to change the original meaning of the data or lose some important details. This is because the number just give an overall impression of the aspect but does not really provide the exact detail of the same. Just like the example earlier, the GPA of the students does tell whether the student performed well in the easy subject and failed the hard one or vice versa. However, regardless of these shortcomings, descriptive statistics are still the best way of summarizing a wide range of data and aid in making comparison between the same. Let's now get an in-depth look at descriptive statistics. Here we are going to look at the concept of univariate analysis. This is basically the examination of different cases of a single variable at the same time. There are three main areas that we are going to look at, which are the distribution, the measure of central tendency, and the dispersion. These are the common characteristics that we will want to identify in our variables. First, let's have the distribution. It is a summary showing the frequency of single values of the ranges of a variable. A simple distribution table will list all their values against the number of person or units each of them had. For example, the simplest way of describing the students' distribution of university students based on their year of study is to list the percentage of students or the number of students in every year. We can also describe the gender of a sample by listing the percentage of males and females or the number of each. In such cases, the variables involved are quite a few such that we are in a position to comfortably list all of them and make a quick summary of the numbers involved in each value. But then, there are cases where the number is too large, like when handling the GPA or income. There are quite a number of possibilities in terms of values, and all the values will carry a few people. With that, the raw scores need to be grouped in terms of range of values. For example, the raw scores can be grouped in terms of ranges of a letter grade, just like what you see in a table. We can also use a frequency distribution to describe a single variable depending on the variable involved. We may represent all of the values or group them into categories. Next, the measure of central tendency. From the term central, the measure of central tendency involves determining the value at the center of the distribution. We have three main measures of central tendency. These are mean, median, and mode. In mean, this is the most common method used in the measure of central tendency. It is the average of all the samples involved. To determine the mean of a sample, you only need to find the sum of all the value involved and divide them by the number of the values. For example, if you want to find the mean of the scores of students in particular test, you need to sum up all the scores and divide them by the number of your students. Another example is to calculate the mean of scores of the marks of 10 students with the following values involved. As you can see here, you just need to add this data, and the sum is 585. With that, 585 divided by 10, which is the number of values, we have 58.5 for the mean. In median, the median statistic is the value found in the exact middle of a set of values. To find the median of a set of values, you will just need to organize first all the values in a numerical order and identify the value at the center of the sample. For example, if you have a 100 values, then the 50th value will be the median. So in our case, let's arrange them in our ascending order first to determine the median. So here we have position 5 and 6 in the middle. Therefore, to get the median, we are going to interpolate them by adding the 2, then dividing them by 2. So 50 plus 63 divided by 2 is 56.5, and that will be our median. In a set of values, the mode is the frequently occurring value. The mode is usually determined by identifying the most occurring number. You will also need to arrange first the numbers in an ascending order and then count each of them to identify the most frequently occurring. As you can see, the most occurring number here is 46. It occurs 2 times in the same set of values, so our mode is 46. Lastly, we have the dispersion. Dispersion is a term used to describe how values have spread around the central tendency. So we have here the two common means of measuring dispersion, and that is the range and the standard deviation. The range is just the maximum value minus the minimum value. For example, the highest value is 92 and the lowest value is the 21. So the range is 92 minus 21 is equal to 71. So our range is 71. In standard deviation, this is the most detailed and the most accurate description of the dispersion. This is because it shows how the different values in a set relate to the mean. So let us first look at our data. To compute the standard deviation, we first need to find the difference between the values and the mean. We have here 21 minus our mean, 58.5 is equal to negative 37.5. 35 minus 58.5 is equal to negative 23.5, and so on until our last value, which is 92 minus 58.5 is equal to 33.5. Note that all the values above the mean have positive discrepancies, while the values below the mean will have the negative ones. The next step is to square all the discrepancies. So negative 37.5 times itself is equal to 1406.24. Again, you will just need to continue to do this until the last data, which is 33.5 times itself is equal to 1122.25. Now we need to determine the variance. Variance is equal to sum of squares divided by n minus 1. We get this by finding the sum of the squares of the discrepancies, so which is the 4754.49, then divided them by n minus 1, so the n is the number of our data, which is 10, then minus 1 is equal to 9. So 4754.49 divided by 9 is equal to 528.27. Our standard deviation is now the square root of the variance. So our variance is 528.27. So square root of 528.27 is 22.98. So our standard deviation is 22.98. This computation seems so very complicated, but it's actually very simple if we use the formula here. It is important to note that it is possible to calculate the univariate statistics manually, but it can be very tedious, especially when dealing with many variables. So there are a quiet number of statistics software that can help us in doing so. An example of this is SPSS. So what is the importance of descriptive statistics? These descriptive statistics are very vital because it helps us in presenting data in a manner that can be easily visualized by people. This therefore means that the data can be easily absorbed by people. For example, if you are presenting the performance of the students in a test, then the measure of central tendency can give an indication of how the class performed. Another is the mode can tell the scores that the most of the students got, and the mean can tell the average performance of the class. And on the other hand, the measure of spread can be used to summarize the performance of a group of students. For example, the range can tell the bracket of the scores that the students got. In general, descriptive statistics is a great way of breaking raw data into meaningful piece of information that can be easily understood by people they are intended for. However, presenting raw data can be sometimes important because it helps in keeping the original information and the meaning is not distorted. Take note that when we use descriptive statistics, it is useful to summarize our group of data using a combination of tabulated description like tables, graphical description such as graphs and charts, and statistical commentary like a discussion of the result. And that's all for today. I hope you've learned something. Thank you for listening and have a great day.